Okay, guys, we're going to do this collisions lab without me. So the instructions say you have to choose explore one-dimensional. And the first thing I'd like you to do is separate the balls all the way to the each end, okay, as far back as they'll go. And we're going to click values. And we're going to turn off the reflecting border. Like if you kept the reflecting border on, after the collision, they're just going to keep bouncing and bouncing. And it's going to mess up our data. So I'm going to reset that and turn off the reflecting border. Okay. In the first part, it is an elastic collision. So we're going to keep elasticity 100%. And they tell us what to do in the table. It says mass 1 is 1, mass 2 is 2. So I'm going to change that to 1. And then I'm going to change the mass of the second object to 3. Bam. And velocities, pew, 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 are going to be 2 and -2. So I need more data. And I need to choose the velocity for the first object as 2. Click. And I need to change the velocity of the second object to -2. Okay, this way they will go towards each other. All right, now they're all the way at the ends. I'm going to do it in slow motion so you can see it real quick. But you see object 1 has a velocity of 2, and they even calculate the momentum for you. So in your chart, you are going to get the momentum total of the system. So the momentum of the first object is going to be the mass times the velocity. That's going to be 1 times 2. So the momentum of the blue ball is going to be 2. The momentum of the pink ball has a mass of 3 and a velocity of -2. So 3 times -2, your momentum is going to be -6. And they even give you the values over here. All right. With that said, you can play it and you can check the velocity after the collision. And you can check the mass after the collision. I can pause this because it's just going to keep going on into infinity, because the law of inertia says if there's no unbalanced force acting on it, no change in the acceleration. So that thing would just keep going on and on and on due to its inertia. So you can pause it anytime after they collide. Now, after they collide, what was the velocity of the first ball? -4. Makes sense because it was going in the opposite direction. What was the velocity of the second one? It was 0. So it came to a stop. All right, you can put the momentum of the first ball is -4. The momentum of the second ball is 0. What is the total momentum of that system? It's -4. So you run through these exercises, and the whole point of it is so you can see that momentum is conserved. So the momentum of both of them before has to equal the momentum of both of them after. The hardest part might be for some of you just getting used to the controls. All right. The first page is an inelastic collision on the bottom. So I'm going to reset this whole thing. I'm going to take my slider. I'm going to go all the way to inelastic. And then I'll run a sample of this. I'll keep my mass of the first ball at 1. The mass of the second ball has to be 2. So I click over here, select +2, hit enter, bam. Now the velocity of the first ball has to be 3. Click, hit enter. Velocity of the second ball is going to be a -1. So you just go ahead and click that on the number pad, and they'll calculate it for you, or you can multiply. The momentum of the first ball before they collide is 3. The momentum of the second ball before they collide is -2. Let's have a collision, and they should stick together like birds of a feather. Okay, and now we have some more values. I'm going to give it an old pause there, and what we've done here is we have, we have changed the momentum, excuse me, of the system. Now they share a velocity. So velocities of both of them should have the same value. So if you were to calculate the momentum of the first ball, it'd be 1 times 0.33 is 0.33. And the momentum of the second ball after they collide, it's 2 times 0.33 is 0.67. Add those together, you get a value of 1. It's the same as the momentum after. Now, you guys are going to be running through several other scenarios with this and some challenge questions. Be able to distinguish between elastic and inelastic. Remember, elastic will bounce off. Inelastic will stay together and form a system. Have a great day.